So I will just pick up from where we left in our last group meeting. So what we did there, we did some plots and we have shown some presentation where we have discussed all these tectonic settings as a whole. So what I was doing in the meantime was I actually classified them. I was actually trying to pick up one particular group and then work on it. Like this time I am working on this intraplate volcanic setup. So it contains like 33,000 data. So that's the bulk of 43,000 total Garnet data I have from the rock database. So I was separating them on the base of rock types this time. So among these rock types, so what I did find out is there is a substantial amount of kimberlite, lamprophite, and xenolith population. Xenolith is really huge. So I was classified it, and I spend a good amount of time in pre-processing of the data, and this will probably continue. Why, I will just show you here. So here I did this plottings here. I first I selected something, then when I plotted here, it's a huge amount of legends I am getting. So I need to find a way somehow to decrease the variance. I decreased the variance a bit and got still a substantial amount of data. So among each of these, like here I'm plotting xenolith as a whole, but even within the xenolith there is a significant difference in composition. So these xenoliths I'm going to separate, and they, and along with the kimberlitic type of garnet, the other lamprophile types of garnet is going to be an asset for this project. We need to separate them individually. Like we have to find out all the rock types that's present in the kimberlitic type of garnets. I mean, of course, kimberlite is a rock type, but like garnet, phlogopite, kimberlite, like this. And so we'll separate them also for the xenoliths. Xenoliths we also have like 10,000 data or so, 10,000 odd data or so. So xenoliths will also be separately classified, and then perhaps once we decipher those tools, like uh, I have also suggested that Urjasi, who is actually an undergrad working in this project, she should separate this. She should translate this the Chinese part of those codes so we can understand it better. And then obviously we need to calculate this Fe3 plus concentration ferric by total iron ratio. So from that we'll get a proper understanding, and then there is this already existing pyroxene code. So for the calculation, for the machine learning purposes, which we can do on a small set of data, small set of test data to select and work on it. uh, so that's more or less it. Somehow we need to pre-process the data a little more and get rid of some of the variances for a larger plot, because this is too much to handle. And then we have to take the data separately and find out what's going on. Okay.
Okay,
Hello?
that's good. Okay, yeah, that's pretty good. Okay, Umi, could you share some of your ideas? Yeah, by the way, I would ask everybody to send me your PayPal account. Tohin has already sent to me, and Arka and Umi, if you have time, send me your PayPal account, because we are going through the payment for the duration of last 3 cycles. Okay. Okay, go ahead.
Yeah, sorry. Yeah. Hello.
Yes, go ahead.
Yeah,
Yeah, we
okay.
could hear you.
Yeah, okay. So I have actually downloaded the PCA code that was used in the last, I think, pyroxene data. So I translated it, the comments part, and then I used the kimberlite data from EarthChem to find out if there is any pattern or not. But the point is, I think we should merge the data from GeoRock and EarthChem, because I see that in Kimberlite data of EarthChem we are getting only 450 rows. That's like pretty less amount of data. So I was trying to see, I was trying to use only the Kimberlite data so that we could actually find a pattern. So the point is here what we see, only these part of the data is showing a trend, but should it have been a similar, if we haven't taken only this data, so it should have had something linear orientation giving the PC1 and PC2. But here as you can see, there are few data points which are behaving opposite to this trend. So this PCA is not really reliable,
Yes,
but maybe we can
sorry,
find
sorry.
out.
Could you please speak a little louder, closer to the mic, perhaps?
Yeah, hello.
Okay, okay,
It's
fine.
okay.
Yes.
Yeah. So when we are plotting the Kimberlite data, what we can see is that some points are behaving pretty different to the other points, and so this PCA data is like these PC1 and PC2 axes are not very reliable. So we have to find out what why these points are behaving differently. So because this similar trend is also showing in the incremental PCA and all. And so I think we should see the data once again. Like I'll see the data of the Kimberlite once again and try to find out why some points are behaving differently and we are not getting that particular trend. Because if we remove some points, we'll get a trend. So I have tried to plot only the Kimberlite part of the data to see if there are some trends, and we can see there are some trends, like between chromium and aluminum we are getting a quite consistent trend, but again we are getting some points that are outlier and behaving in a different pattern. So maybe we can find we'll try to find out why these two different patterns are we are seeing. And other minerals like MgO and FeO, Fe total, they are also showing some trend. But these outlier points, they have to be seen why they are showing this. Like calcium and aluminium and chromium. Calcium is showing some linear relation with aluminium and chromium, but again we are getting some these points. And again for null values, I have null values have been replaced with 0. So these 0 values can be explained by that. But these outliers have to be taken care of if they are altered samples or something of that sort has happened. So and another thing is that for Kimberlite in ArcChem data, as I said, the values are pretty less. So we can, yeah, and if I have separated out the major element data and the trace element data in Excel itself, and then for the PC I used only the major element data, and we can see that for major element data we have like 450 points, whereas for trace we have further less points. So maybe we can merge the Earthrock data, sorry, the GeoRock data, because there are far more number of points there. So then we can join the Kimberlite or similarly that rock kind of data, and we can try them again. And another thing, this part, MG2. Yeah. So yeah, and this plot that last time I had shown, that above this particular line, this portion of the data, that this portion of the plot, they show the mantle signature. So we can see the Kimberlite points that we have, they show the mantle signature, and they are we don't have crustal mixing. This point is possibly some outlier which we can delete, and so that's what I have done. I have seen. That's it.
Okay, thank you, Wumi, for sharing. So do we have any other more comments? Yeah, by the way, I would like to add it up that to him in the tonight you're going to give a presentation. So
Yes.
actually, so everyone, let's, I think not everyone, there are only few of us, to send a photo. I'm going to send my photo and Natasha photo to him so that you can put it in a cover page. And
Okay.
then in the talk, you could talk about the data set that we have. You could have some guidelines like data set we are building, we are thinking of working on Mendel's redux, which is very crucial for various different questions. I'm going to send you a paper later on. And then what we have worked on now and some of our very preliminary investigations on the GeoRock data set and Earth chemistry data sets and how they looks like. And you don't
Yes.
have to talk too much
Yes.
about
Sure.
details as what
Yes.
you presented today, 2 days ago and today, and just give a very, very brief idea to other group members because
Oh.
we only have 5 minutes. So,
Okay.
so it's very limited. You probably
Okay.
are only going to show, I think 6 to 8 slices. I think
Okay.
that's enough to make it clear.
Okay.
Yeah, yeah, and take your time. Don't speak fast and speak slowly so that people could understand.
Okay.
Yeah, that's it.
So it will
So,
be like in 9:30 p.m. Beijing time, na?
yes,
Okay.
9:30 Beijing.
Okay.
Mhm.
Okay. Because so as we can see here, like to understand this redox of the mantle, probably we'll take those ones that are showing this mantle signature as Urmi has already shown, and I'm about to do this kimberlitic and peridotic or mostly the xenoliths. Xenoliths will take a very important role in all of this. So the xenolith data itself from all the settings, like I have separated them from the intravolcanic
Yeah.
setup here. So from all the settings, we will classify xenoliths in a proper way and then decrease the variance, make some plots, do some
Yeah.
PCA, and then we'll try to find it out. Yes, Dr.
Yeah,
Chang?
yeah, yeah. I think you could only show one or two plots is enough. We could talk about 20 in our meeting, but you just show one or two is enough.
Yes,
Yeah,
yes, I'm
definitely.
talking about the
Yeah,
future versions.
Talk something about how the data comes from. Talk about the quality of the two data sets in
Yes,
Earth chemistry and georock, and
yes.
then talk about let's say how divide them by the rock type, how
Hmm.
divide them by the tectonic setting, because Johin, you and Umi divide them by these different ways. So each of the ways you could talk a little bit about it.
Yes,
And then at the very beginning, talk about the, like say, the overview of the possible scientific questions and the data set. And then I think then that's enough. It's already 6
yes,
slices already, I think. Yeah, don't show too many plots. I think
yes.
if you show us 3D plots, then one slide only need to show one plot. If you
Hmm.
are going to show 2D plots in X, Y axis, you only need to show 2 plots in one slide.
Yes.
Then I think that's enough. It
Okay.
should be enough. Okay. Yeah, you could also see what other people are doing, and then that could also broaden our horizons. So it should be interesting.
Yes.
Okay. So do you have any other questions? So Arka, do you have any questions?
I have something to ask. Yeah.
Yeah. Wumi, please go ahead.
Yeah. So I have downloaded when I downloaded the PCA code. So there was a test set for that has been used for pyroxene, and in one of the columns, true values are given like -1, 1, and 0. I was wondering what these values actually stand for.
I think Ben could answer it. I think they divided into, it's a marker, it's a label. So Ben, what does it correspond to? The label -1, 1, and 0. Okay, I think Ben is in the office, so he's typing. Yeah, I don't know. Maybe it's some mathematicism or something like that. I think he also needed to check it out. I think Wumi, you could post this question again
Yeah. Okay.
in the Slack
Yeah. Okay.
for the overall. I mean, not only for Garnet, but in the biggest chatting group. I think they should be able
Yeah.
to.
Okay.
In each group, they define it as something different because some group they do it for the hydrogen diffusion or not diffusion and using as a -1 + 1. And some other groups, they say this is mesosomatism or something. So yeah, I think he could answer. Yeah, should be okay. Yeah, please post it at the Slack. Okay, do you have more questions, Umi?
No.
About this,
I'll ask
like
again when I heard something.
about this, what we are, amalgamating the two sets of data. I mean, keeping them together. So I think Orko or Urjashi, somebody is on it. So probably.
I am actually downloading the data of the Mozambique data for Garnet's. I'll do that from Artcam and Georock. And I had a question of this is for Tuhinda. You said something about downloading or listing the DOIs. What is that for? Like the
Like
DOIs of
we'll,
papers.
I mean, it will be because we cannot use the data blindly, right? So, see, we have to check it out
So
for
that's the
almost
paper
for all the
database
individuals.
basically.
Yes, basically.
Yeah. Okay.
So DOI number is a specific code for a particular publication. So you just look at the code, you know which publication corresponds to, and each publication has a unique DOI number. So that's why we need it, because in the future, people want to sort out whether there are the same publications in the same data set. So that's one of the easiest way to check is by looking at the DOI number rather than looking at the titles. Because theoretically the titles are the same if it's the same publication, but the problem is that a lot of titles contain certain symbols like a dash, slash, or comma, and that will sometimes that will make a lot of problems. So for DOI, it's just a code, it's just numbers, so it's very easy to compare with each other. That's why each publication has a unique DOI number, and that's why we need this DOI number for any future use that we want to link a paper to any data or to any title or abstract or anything.
Okay, I guess this clears it up.
Yeah.
So
Okay.
okay.
Yeah. Okay. Ben says he's not sure it's his code. So yeah, please post the question into the biggest group. I think somebody probably knows because there must be someone who wrote it.
Okay.
Maybe it's Wei Hua's group that did that. Yeah. Please post it, then I will follow it up. Okay.
Okay.
See you all tonight, hopefully. And yeah, send me the PayPal account if you have not sent me to. Okay.
Yes.
Great.
Okay. Bye.
Bye.
Bye.